11.4. We'll be working on that today. Something called the side splitter theorem. In the side splitter theorem, we're going to be talking about how if you have a triangle in which there is a set of lines that is transverse or split through the middle by a set of parallel lines, you end up with proportional sides. So like AB, which is the longest side within this diagram, is proportional on one side, long to short, and it could be short to long. It doesn't matter which side's longer, just as long as they're parallel lines, but they have to match up, is to the long side of the other end is to the short section of the other end. They form a proportion, and since we're talking about proportions this chapter, this fits in a lot to what we're talking about. The same thing occurs if you have a triangle, but one of its angles has been bisected to the other side. Again, we have the longer side of one edge as to the shorter side, and the larger side is proportional to the shorter side. One of the ways that you can visualize this is it's always proportional in this fashion: long to short and long to short, B to A and D to C. Here's a corollary of the side splitter theorem, and that means it's saying basically the same thing. Just in this particular case, you have only parallel lines. They don't go to a triangle, and we could use the same pattern that we've been working on in the last couple. Taking one side, the short over the long, as to the other side, the short over the long. That should work for all applications. Here's another example of the side angle bisector. Again, it doesn't matter which way, just as long as you match them up properly. So as 18 is to 12, as 24 is to x. So now we can kind of cross multiply. Multiply the 12 this direction and the x this direction. So we'll have 18x equals 12 times 24. So we do 12 times 24, and we'll get 288 equals 18x. Divide by 18, and we will get x equals 16. Alright, so x would equal 16 in this case. Does that make sense? You can see it's greater than 12, obviously shorter than 24, but it sets up a nice little proportion. Let's look at another example. In this case, remember, just like we said before, if we were to get my highlighter out, here's the shorter side, and here's the shorter side. So those would be proportional. So we could say, I don't want yellow, that doesn't show up very well. 2 and x, and just as long as this is on the top, this one has to be underneath it. 4 and 7. Okay? So we can cross multiply again, just like before. So we have 2 times 7 equals 4 times x. So we'll get 14 in this case equals 4x. Now that's not going to go in evenly when I divide. So if we do 14 over 4 equals x, we can reduce that to 7 over 2, because 2 goes into both the numerator and denominator. So I take 7 over 2 as the exact answer, the approximation The divided out answer would be x equals 3 over 5. Both of these you'll find to be acceptable. I've noticed that about half of you are going one direction with this and half of you going the other with your answers. I accept both, and I want you to know that, okay? So here it says use the side splitter theorem to solve for x and y respectively. So we can do the same thing here. We can say 6 is to, what would we put it over? Sorry, this 6. I just noticed that there are multiple 6's on this. So that 6 is over x. You know, it's pretty simple. If you just continued the line out like that, that would kind of help you. As 18 is to 6. So we could cross multiply the 6 that way and the x that way. So we have 6 times 6 equals 18 times 6, or 36 equals 18x. 18 just happens to go into 36 evenly twice, because 2 times 18 is 36. So x equals 2. Now the same proportion would work for those parallel lines also. You got to make sure that these are parallel lines in order for this to work. So we could say 6, or let's not go with 6. Let's go with 18 is to 6. So I did this side over this side, as y is to 20. Okay, so we could cross multiply 20 times 18 is as to y 6y. 20 times 18 equals 360 equals y, and so y would equal 120. Oh, excuse me, not 100. I left out the 6 there. I missed that. And it equals 60. Okay, so this would be 60. As you can see, there's a k factor of 3 that's involved in this proportion. Everything is multiplied by 3. K equals 3. K equals 3. K equals 3. I don't think it really matches the diagram. This 18 and 6, I grabbed this off of the internet someplace. That's a little distorted. It's a little out of whack. I wouldn't think that that's how those numbers would line up. I'm thinking that all of the tops would have to be shorter than all the bottoms. Anyways, okay. All right, let's move forward. Here's another proportion. It says, again, long, VW, or the short, the top over the bottom, and the top over the bottom. Not a super hard concept for us to see. Just as long as we get it, we keep it all in order. Here's VW on the top, and here is WY on the bottom. So they're proportional. Yellow is to green. As, let's see, make XZ orange. Yellow and orange look pretty close with a purple background. As to VX, the purple. Okay? So hopefully you see top over the bottom, how that ends up being proportional. Again, if you want kind of a handy thing to help you, you just put like your bar right there for your fraction bar for your proportion. All right? Hopefully that helps you with this lesson. Again, I'm making your homework less each night. So tonight, your homework is going to be, I wrote this down, page 543 to 544. I'm going to do numbers 1 to 5. And 1 to 5 is stating the proportions. And then I'm going to have you do 9 to 12. So these are like stating the proportions. You're going to do like like on the last slide, like VW is to, I don't remember what it was on the last slide, WY as, and so you'll just set up the proportions. On these ones, you're going to 9 to 12, you're going to solve the proportions, where you're actually going to get the value x equals 10 or something like that. Okay, let me know if you have any questions about this homework. You have a good night. I will see you tomorrow.